All attendees are in listen-only mode.
Hello, everyone, and welcome to today's webinar. Our webinar today is we're going to be talking about luminance, radiance, and photorealistic rendering in TracePro. One quick note as we're going along, we are recording this webinar, so we will have a recorded version of this webinar up on our website within the next day or so. So if you do want to go back to it in the future to look at it, you'll be welcome to do that. So just to introduce myself, my name's Dave Jacobson. I'm a senior application engineer here at Lambda Research. I've been here about 12 years or so. Previous to this, I was with EG&G and PerkinElmer, working as an optical engineer, and a longtime TracePro user as well. So the format for today's webinar, we're going to do a 30 to 40 minute presentation, and then we're going to follow that up with a question and answer session. At any point during the webinar, please feel free to enter questions using the question box in the GoToWebinar control panel. And then what we'll do is we will address all questions at the end of the webinar. And I'll try to remind you about that as we're going along as well. Before we get started, just like to let you know about a few additional resources relating to some of our products, especially TracePro and Oslo. We have webinars and tutorials available on our website, tutorial videos, as well as other tutorials, and then information on upcoming training classes. At this point, I think the listing for the upcoming training classes is blank, just because we're not sure what our training schedule is going forward for the next few months, given the current situation with COVID. But as soon as we have some solid information there, we will be updating that. Okay, so let's start a little introduction here on what we're going to talk about today. So as I mentioned, our main topic today is we're going to be talking about luminance, radiance, and photorealistic rendering, and how you can do that in TracePro. Before we can really do that or really dig into that, I think it's important that we have a bit of an introduction and a review of radiometry and photometry. You know, what do those terms mean? How are they related or unrelated? Then we're going to get into why do you actually need to do luminance, radiance, or photorealistic rendering? You know, what's the justification for it? Then we'll actually go into setting up actual luminance, radiance, ray traces in TracePro. How do you do it? What are the steps involved? Also, while we're doing that, we'll talk about setting up photorealistic rendering in TracePro. Getting down towards the end, I'll talk about some of the options, some of the settings you can change to change the way the plots look. I'll show some examples that we've done in the past. And sort of as the last section before we hit our questions and answers, I'll just jump over to TracePro and I'll show you really how easy it is to set up photorealistic rendering and luminance and radiance ray tracing in TracePro. It could seem a little daunting at first, but it's actually fairly quick and easy to do. And then, as I said, we'll wrap up with a question and answer session at the end. So, a little review of radiometry and photometry. So, radiometry, it's the measurement of electromagnetic radiation. In the most general sense, we're going to include everything from X-rays to microwaves and radio waves, with wavelengths ranging from less than a billionth of a meter for X-rays to greater than a meter for radio waves. If we start talking about optical systems, which is really where we start to think about this in TracePro, we could probably limit this to, say, the ultraviolet to the infrared, maybe 0.1 microns for vacuum UV, out to 10 microns or more for the far IR type applications. If we divide that down even a little further, and we look at common detectors, things like CCDs and photodiodes, you know, these are silicon-based detectors, and they have a sensitivity range of 0.2 to 1.1 microns. I mentioned microns because microns is the wavelength measurement unit we use in TracePro, but if you're used to nanometers, 200 to 1100 nanometers. And the standard unit of radiometric or radiant flux is the watt. Now, photometry is a little bit different. Photometry is the measurement of light as it's perceived by the human eye, or your eye. Your eye is sensitive to light from about 0.4 to 0.75 microns, and this is the region we call visible light. Now, one interesting thing is that your eye is not equally sensitive to all wavelengths in this range, and I'll show you a graph in a minute that shows that. The peak sensitivity of a light-adapted eye, meaning you're sitting in a well-lit room or you're outside in the sunlight. But the peak sensitivity for a light-adapted eye is 0.555 microns. And this is actually green light. And then our standard unit for visible or luminous flux is the lumen. Here's a chart that's probably in every basic physics book out there. We have the electromagnetic spectrum along the bottom, from radio waves to gamma rays. And then in the middle, a very small slice is radiometry or photometry. It's visible light. So radiometry covers that full spectrum. Photometry covers just the visible spectrum. Now, I mentioned a few minutes ago that the response of your eye is not uniform. Here's the human eye response, and this is called the photopic curve. And this is a light-adapted eye, meaning, as I said, you're in a well-lit room or you're outside during daytime. And you can see the peak output, the peak response of your eye is at 0.555 microns. And 1 watt at 0.555 microns is defined as 683 lumens. Now, there's another curve for your eye response that you hear about occasionally. That's called the scotopic curve. And that's the response of your eye when it's dark adapted. You're sitting in a dark room, you're outside at night. And as you can see, the response of your eye shifts from being a peak in the green to being a peak more towards the blue end of the spectrum. Part of this is really the reason why if you're working outside at night or working in a dark room, you can use a red light and not sort of destroy your night vision. It's because your eye is just naturally less sensitive to red light when it's dark adapted. So when we deal with something like TracePro, and we're doing our analysis in TracePro, there's 3 common types of measurements that we work with. Radiant or luminous intensity, which is flux per solid angle, irradiance or illuminance, which is flux per unit area, and then the last one, radiance or luminance, which is flux per solid angle per unit projected area. In this webinar, we're going to focus on that last one that I have circled there. Just note too, in the way I have these ordered, the radiometric term is first, the photometric term is second. The reason I started adding slides like this to a lot of my training classes is that the terms are so familiar, or so similar in the way they sound. You know, irradiance, radiance, luminance, illuminance, intensity. So it's very easy to get confused. So I've put these slides in sort of as a backup, or if somebody's not familiar with the terms. So again, we're going to focus today on radiance and luminance for the most part, along with photorealistic rendering. Okay. And here's a graph or a picture, kind of what those terms look like. You know, the output from our lamp here, that's our radiant and luminous intensity, if its output is a function of angle or solid angle. The light falling on a surface, a flux per unit area, that's our irradiance or illuminance. And then what you see for an eye or a detector of some type out here, you know, if you put your eye here, what you see coming from that surface is actually, that's the radiance or luminance. Now, obviously, if it's what your eye is seeing, it's luminance. So just a little more information on that for radiance and luminance. Radiance and luminance, it's the flux per solid angle per projected unit area in either radiometric or photometric units. It's a measure of light from an area that falls into a given solid angle. When we're dealing with radiance, our units are typically watts per square meter per steradian. And when we are dealing with luminance, the typical measurement is the candela per meter squared, which is also called a nit. Same unit, same measurement, just different names. And then there's also other terms, things like foot lamberts, millilamberts, that are less commonly used for luminance. An interesting fact about luminance and radiance is that they're distance invariant, meaning that as you get further back, the value stays the same, with the caveat that your solid angle remains smaller than the source. So you have a viewing angle, and as long as you're viewing the whole target as you're going back, your radiance luminance will stay the same. When that viewing angle subtends an area larger than the target, then it's obviously going to fall off. And then lastly, as it relates to this, photorealistic rendering is a lit appearance display of an object as it would appear to a viewer. So kind of what your eye sees. Now, another term that pops up occasionally is brightness. And brightness is one of those terms that I don't like it myself, but I will freely admit to I use it quite often because it's a term most people sort of understand what it means. But brightness, and this is taken from the Wikipedia definition on this, it's an attribute of visual perception in which a source appears to be radiating or reflecting light. So in other words, it's a perception elicited by the luminance of a visual target. And really what I like is that next paragraph there, that brightness was formerly used as a synonym for the photometric term luminance, and incorrectly for radiometric, the radiometric term radiance, because your eye can't see radiance. Typically, you're looking at luminance. And now, according to the U.S. Federal Glossary of Telecommunication Terms, which I wasn't aware there was such a thing until I just did this the other day, brightness should now only be used for non-quantitative references to physiological sensations and perceptions of light. So brightness is kind of it's an ambiguous term, I would say. But it's one of those things everybody kind of knows what you mean when you say it, but there's no real measurement for brightness. The closest analogy is luminance. And just mentioning something like that, this is a box for an LED light source that I found at one of the large big box home centers. I got this a year or two ago. And I look down the bottom, and it's one of those things that makes me laugh, but it says its brightness is 325 lumens. So first off, there's no real measurement for brightness, and if there was, it certainly wouldn't be in lumens. So I just always thought this was kind of funny, and I blacked out the name of the company just so that, just to cover that up. But this is sometimes you see things like this in marketing and in packaging. So just note, brightness is closer to luminance than, say, output. Okay, let's actually start talking a little bit about luminance, radiance, and photorealistic rendering themselves, especially as it relates to TracePro. Now, in this example, what I did is I made two light sources. The one on the left is 100 millimeters squared. It's a 10 by 10 light source. The one on the right is 1 millimeter squared. And I gave them both 100 lumens of output. But as you can see, when we look at the photorealistic rendering, the luminance, the quote-unquote brightness of the one on the right is much higher. it looks like there's more output there. Matter of fact, I'm oversaturating the image on the right just to even show the basic, just to show the light from the one on the left, the larger source. It's a little easier if we switch here in this next slide. We actually look at it in luminance values, in this case nits. And just remember, nits and candela per meter squared are the same thing. But again, 100 millimeter squared versus 1 millimeter squared, both with the same number of lumens, both have the same luminous flux. So if we stuck these in an integrating sphere, we'd get the same measurement. But on the left, we have a luminance of probably somewhere around 1 times 10 to the 7th nits. On the right, we're at 1 times 10 to the 10th nits. So 3 orders of magnitude higher in luminance. In this case, I'm in a log scale as well to be able to show this. So we're multiple orders of magnitude higher in terms of luminance than we are when we spread that light source out. So just note, if you keep flux constant and you reduce the size of the emitting area, the luminance is pretty much going to go up. If you keep the flux constant and increase the size of the radiating or the illuminating area, luminance will go down. I guess another good analogy to this would be if you looked at a 4-foot long fluorescent tube, and then you took an LED that had the same output of that fluorescent tube, which one's going to look harsher to your eye or brighter to your eye? The LED is, because it's compressing all of that light into a smaller area. So just a couple examples here of setting these things up in TracePro, or not setting them up, but just some displays from TracePro. And I'm going to mention as we go along, we have a couple different ways we can do luminance and radiance in TracePro. This is one method. This is a different method here, and I'll talk about those more shortly. In this case, this is a light guide with our name and logo on here, the TracePro name and logo. And we're looking at luminance in candela per meter squared, or nits. And this isn't the most high resolution image. This was a relatively quick luminance ray trace here. So that's why it doesn't look as clean as it could. But one option we have when we do a luminance radiance trace here, a luminance ray trace in this example, is we could switch our units to foot lamberts or millilamberts. So for those occasional applications where you still see specifications in foot lamberts and millilamberts, you can get that information in TracePro. Okay. And then similar switching to radiance. So now we're looking at the wider electromagnetic spectrum. Our units now are watts per meter squared per steradian. We are just changing our units here. And what's nice is we don't have to rerun the ray trace. We can just change the analysis units and see the difference in results. Now, a question might be, why do we need to look at luminance or radiance? We have other tools in TracePro that can talk about the light output, things like illuminance, irradiance maps, candela plots. Why do we need an additional measurement? Well, here's an example. I'll try to show you why you might need this. Very simple light guide. We have an LED at one end. We have a light pipe or a light guide here, just a square profile light guide, and we're interested in the light coming out here. This could be an indicator display or something. There might be, a space between the PC board where the LED is mounted and where the display is. This might be an on-off, things like that. Okay, so we're interested in the light coming out the end of this light guide. So first thing we might do is, well, once we set up the model, let's run a ray trace, and we're going to look at an illumination map. I'm in visible light here, so I'm going to stick with illuminance maps, but the same applies to irradiance as well. But here's the illuminance for the light coming out of this light guide here. What I actually did is I put a small target surface here at the exit of the light guide. The reason I tend to do that with light guides, and people that have gone through some training sessions with me have probably heard this before, is I'm interested in the light that actually gets out of the light guide. So I'm not really interested in the irradiance or luminance directly on the surface. I'm interested in the stuff that actually makes it out, because we can have reflections off the surface and things like that, TIR. So I put a small target, thin target, just outside the light guide. So I'm looking here, just looking at some quick values. I'm about 70%, 71% efficient. So not the most efficient light guide. But I have a nice uniform illuminance pattern here. Looks pretty good. So, okay, I'm off to a good start. What about the angular distribution, the candela plot or the intensity plot? Well, again, light coming out of this light guide has a nice distribution. I have a good, a good field of view from this light guide. So if I'm out here at this, let me see if I can turn a pen on here if I can find it. There we go. So if we have a viewer over here, bad drawing of an eye, but looking at that, well, there should be a good amount of light coming out there. The viewer should be able to see this. So again, looks like we're going in the right direction. And let me see, erase that. Okay. So far, so good. We could just ship this to the customer right now and say, oh, it's done, good illumination pattern, good angular distribution. But before we do that, let's take a look at the luminance just to be sure. Okay, go to my next slide. Now, here's what we see when we look at the luminance map. And again, I'm looking straight on in this case. The other views were just, they were also straight on because I'm looking at the light hitting this target, but just so I could show the whole light guide. But looking this, if I was a user and I was looking straight at this light guide, I'm not going to see a big, large illuminated area like I'm hoping. I'm actually just going to see the emitting dye, in this case, the emitting dye of the LED. And that's, you really can't see that here. The covering on the LED is hiding at that yellow dome. But I'm seeing just the emission area from the LED. And if I actually look here, look at, I am in luminance now, very high luminance, 2.2 times 10 to the 5 nits. So we're not going to see what we're hoping to see. We're not going to see this big, I think this is 10 millimeters by 10 millimeters on this LED. We're not on this light guide. We're not going to see this nice big display, almost a half inch by a half inch. We're going to see this small little dot. And I can kind of back that up if I switch over and look at photorealistic rendering. For this example, I only traced green light, I think 0.5461 microns. So that's why this is green. I only used green light in my simulation. But again, we're not looking as good as we hoped we would. So if we had shipped this out, the customer might be rather disappointed. So fortunately, because we did that luminance and photorealistic rendering, we know we need to make a change. So in this case, what I said is, well, what if we add a texture to that light guide, the output surface of that light guide? So just the very end surface of the light guide. And now you can see we get much better results in terms of our luminance and radiance. Instead of having that one high luminance spot in the center, we see a nice distribution of light, nice clear indicator that LED is actually turned on for some reason. And if we look at that here in terms of luminance values, we're at about 3,000 nits. So we do lose luminance, but we do that because we've spread it out over a larger area. So hopefully that kind of gives you an idea, why do you need to do luminance? Why should you check that? And I like to say in any application where somebody's eye is going to be looking at something, or if somebody's going to be looking at something with a camera or a detector or something like that, it's pretty darn important to run a luminance or a radiance ray trace to see how that actually going to look. How's that actually going to look? Because we need to take into account both the source emitting area as well as the field of view. And the only way we can do that is with luminance and radiance. So now, how do we do this in TracePro? That's really one of the main things here is how do we set up these things? And I'm going to give a quick overview here. And what I'm probably going to do in the coming weeks or so is I'll add some more videos to our website going more in depth on step-by-step setting it up. But just now to give you a quick overview, and then I'll show it in TracePro itself. But we have two ways to run luminance and photorealistic rendering in TracePro. And that is, we can either go to the View menu and then go to Photorealistic Rendering, or we can go to the Define menu and select Luminance and Radiance. And they're actually separate ray traces, separate methods, and I'll show you some of the differences. If we want to run Radiance ray traces, we need to do that by going to Define Luminance Radiance. The View Photorealistic Rendering option does not give you a Radiance option at this point, just the Luminance and Photorealistic Rendering. So if you're going to the View menu and using the Photorealistic Rendering tool, what you could do, or basically the steps are, orient the model to have the view that you want to use. So just rotate the model in TracePro. How do you want to look at it? I will always suggest using a small window size initially, because the size of the window is going to control how long the process takes. You could then go to the View Photorealistic Rendering Setup, and that lets you set the parameters for the rendering. And then lastly, to actually run the rendering, go to View Photorealistic Rendering Render. And here we're going from here's the model, go to View Photorealistic Rendering Render, and then here's the result, what that looks like. And I'll show you this live here in a few minutes. Now, once you've run the rendering, if you either right-click in the view window here, the display window, or if you go to View Photorealistic Rendering Options, you can change the options. You can change settings for things like brightness, contrast, gamma. We have an option for saturated color, so that if in the photorealistic rendering, if the output is too high in some pixels, they'll show in a different color. But we can also switch to luminance, and it's this map type here. There's a drop down where we can switch from photorealistic rendering view to a luminance view without rerunning the ray trace. So same ray trace here, just two different types of results. Now the other way to set this up, and people that have been using TracePro for a long time, this is the method that's been in there for quite a number of years, ever since I started using TracePro, which is I think 20 plus years ago now. So the way we do this is we go to Define Luminance Radiance, and then we can set the parameters for the ray trace. These settings then determine the eye positions, the target positions, and this target size. And if we're doing luminance or radiance, well, that's determined by how we have our analysis units set. So if you go to the ray trace menu and ray trace options, you can change your analysis menu, analysis units from radiometric to photometric or back and forth there. And obviously, if you're in photometric, it'll be luminance. If you're in radiometric, it'll be radiance. And here's what that looks like. I used the same light guide example here, and it's the one I'm going to use in a few minutes. But we're setting an eye position, which is right here. It's sort of the apex of this pyramid. We're setting a target position, which is the base of the pyramid. And we're also setting the number of pixels that are within this target here. The more pixels, the better the resolution, but the longer the ray trace will take. And then to run this, it's a different ray trace in TracePro. So you run it by going to ray trace and then luminance radiance. And to change the or once you finish, once the ray trace finishes, you can actually see the results by going to Analysis, Luminance, Radiance Map, and that'll show you the results. Now, one advantage of doing radiance and luminance maps this way is that you can define multiple eye positions, multiple target positions. So for example, on this light guide, we could set up one luminance map looking straight on. We could set up another one off at some angle. We could set up another one off at an even larger angle. And we could go back through that, or we run that, and they're actually ray traced sequentially. So if I go to ray trace, trace, luminance, radiance, it'll do them one after the other. And then you can call up and see all of the luminance, radiance, ray traces in one batch. So here's what that looks like when we're seeing straight on, and then when we're seeing at an angle from the side, we're actually seeing this LED much more so. So this design, I probably need to add a tube or a blocking or a baffle or something in the center to cut down on that high luminance that we're seeing right there. So we're seeing actually, if we look at our maximum nits here, it's 60,000 versus 14,000. So we're seeing very high luminance just from that LED, so that's why we're not seeing the rest of the light guide here. It's just beyond the dynamic range of the plot. And again, you can, for setting options, go to the Analysis menu, Luminance, Radiance Map Options, or right-click in the map window and select Luminance Map Options or Radiance Map Options. Okay. So show you some quick examples, then I'll show you, what this all means in TracePro, how we can set that up. So just a couple things here. Here's a photorealistic rendering of the light guide I'm going to show you in a few minutes. This was a long overnight rendering. So I set it up when I left the office, and then coming back in the morning, I was able to get the final results. In this case, we also have ambient lighting set up. So in addition to the light from the light guide, this is set up so we have an outside light source illuminating the whole thing, which can be useful if I want to make sure that this light guide can overcome the ambient lighting conditions, whether it's in a car or an office or somewhere else. So I want to make sure there's enough luminance here to overcome the background luminance. Here's a speedometer, a crude speedometer model, but this is set up with a light source inside the speedometer, and then we have sort of like a laser etched paint effect here with black paint over a white base, and we can see the illumination of the speedometer from the inside, as well as we have a light guide here as the pointer, the needle. So that's being illuminated from an LED inside here. Another example of a light guide, and I usually have to say, please excuse the shameless self-promotion, but this is a light guide example I made a number of years ago with our name and logo on it, TracePro name and logo, I should say. The one on the left, there's no bulk scattering. This is a clear plastic piece. And we can see things like the reflections of the light guide on the back. And the way this light guide was actually made, or would be made, is the letters are machined into the surface, and then they're filled with a red semi-transparent paint and a white semi-transparent paint for the rays, and white LEDs at each end. So here's clear plastic, and here's a plastic with a diffusing material mixed in, let's say titanium dioxide or something like that. So we have something mixed in there. So we change the total look of the light guide just by changing the material. But again, very easy to run these in TracePro. And TracePro will model, as you can see, photorealistic rendering and luminance with bulk scattering. Also a newer feature from a couple years ago is we can also use ray files as sources as well. So if you download an LED ray file, that can be used as a light source in a rendering and luminance ray trace. Okay. Same thing, but now just looking at luminance instead of photorealistic rendering. Here's another example of a laser etched paint. So we take a light guide, then there was a layer of red paint put down on it, and then on top of that there was a layer of black paint, and then the black paint was etched away in spots to just leave the red paint. So we have this display here, and when we look at it, again, there's some ambient lighting turned on in this case, so we could see the outline of the light guide. In this case, it's coming from the same sort of eye position where your eye would be at. So it's illuminating the front of this. And here's what it looks like in luminance mode with nits. And you can see we would need to do some work on this design. There's not as much output in the center as there is on the edges. So it could be improved. And then lastly, another design that could stand a little bit of improvement, but here's a backlight of some type. We have an LED here. We applied a reptile texture to this. If anybody's seen the webinar we did a number of years ago on reptile and reptile optimization, texture optimization, this was the example from that webinar. So we looked here and we have that texture, and we can see we've got hot spots when we actually look at this. These little hot spots here are actually due to the reptile dots, so we'd need to make some changes there. And then looking at that same thing in luminance, but on the left is a linear scale, on the right is a log scale. So just the two different ways of looking at it. Okay, before I jump into summary and questions, let's take a look at how to set these up in TracePro. We're still looking pretty good on time. So I'm going to go here. And here's that model that popped up a few times in my demonstration there, my talk. So if I want to do a photorealistic rendering of this, first thing I'm going to do is I'm going to set it to the view I want. And as I mentioned, I'm going to keep the window small so we're not here all day watching my ray trace counter go up. Let's say I want to look at it like that. Then I'm going to go to View, Photorealistic Rendering, Setup. If I wanted ambient luminance, I'm going to turn that on here, but I'm going to leave it off for now. If you do set ambient luminance, you can set the direction it's coming from. We have 5 levels of rendering quality: low, medium, high, extra high, extremely high. And each successive level, as you would expect, takes longer to complete. So I'm going to pick medium. And we can also set the number of photons we want to trace. For now, I'm going to set just to 10,000. The results won't be that good looking, but it'll run pretty quick. If you set this to 0, it's going to automatically pick the number of photons, and it's going to pick the number it should be best to get you the best resolution. But a lot of times, especially when I'm first doing it, I start with a small number of photons. So and then I'm just going to click OK. And then to actually do the rendering, it's View, Photorealistic Rendering, Render. Okay. Now it's going through the first part. It's doing the ray trace. And then it's going to go through the rendering passes. And a medium quality rendering is 2 passes. So if this starts to take too long, I'll stop it, but we'll see where it goes here. Okay, so that's through the first pass, now into the second pass. That actually looks pretty good. We can stop that right now. It's going to take another minute or two to finish, so I'm going to stop it there. Okay. Now, this one I must have had my plot set to luminance. Normally it defaults to true color. So you would see this when it finished. I didn't mention, but these are blue LEDs in this example. So if I want to make some changes here, I just have to right-click and go into the photorealistic rendering options. And I could do things like turn on saturated color. So now anything that's in yellow is a saturated pixel. So it has too much output. It's beyond the range of the dynamic range of the plot. So I could, for example, try turning down my brightness level here. But the luminance from the LED right here is going to really swamp that. So I'm going to turn that off. And I can turn this. I'll let those saturate a little bit. But we can start to get a feel for what does this light guide look like when we illuminate it. And we can see we've got some hotspots right above the LEDs, as we'd probably expect. There's other settings we can change here, things like contrast and gamma, change the color curve. But also very easily, I could switch here, the map type, I could switch to luminance, click apply. And now I have my values in nits. So I can very easily switch from a qualitative to a quantitative result without having to rerun the ray trace. I have options here, things like grayscale or color. Do I want a log scale? Do I want to show the legend? Things like that. So we have a lot of different options we can do for that. Okay, so that's how easy it is to set up the photorealistic rendering in TracePro. If I wanted a different view, rotate the model, repeat the process. Okay, so I mentioned we have two ways of doing this. The other way, I'm going to make this a little bigger so we can see it. I'm going to change my view here. The other way is the way that's been in TracePro for a long time. And what I can do there is I can go to define luminance radiance, and I'm going to give it a name, luminance 1. And then I can set my target size. Where am I looking at? What size is this here? And if I look at this light guide, it's about 19, 20 millimeters in radius. So I'm going to say 40 by 40. Where am I going to look from? So where's my eye going to be at? And let's say I'm out at Z is 100. We'll leave it there. And the front position is Z is 15. That's where my target is. And I'm going to click Insert. And I can show you that just by rotating this. That basically where we're looking from is right here. That's my eye position. Where we're looking at is the target position. And then this target has a size. So if I made this bigger, let's say 60, oops, go here to luminance, select that, and I said 60 for the width. I could modify that. So if my target was larger than this or smaller, I could change that. And the way this ray trace works is it traces rays from the eye position back through each of these pixels back towards the sources. So to control the resolution of this, we can do things like changing the pixel size. I could make the pixel size smaller, so we have more pixels, more resolution. And I can also change the quality level, low, high, or custom, which is the number of rays that are traced through each of those pixels. And just for a quick check here, I'll do low and I'll do 2. This is going to be a very crude looking version of this. But if I have that set up, I can then go to Ray Trace, Trace Luminance and Radiance. Okay. And I can either click Display Map here, or if I had closed this out like that, I could go to Analysis, Luminance, Radiance Maps. And here we see it. It looks very crude, very low resolution. Here's our large pixel sizes. But we could use this to get a quick feel for what that looks like. Now, to change options, right-click, go into Luminance Maps options, and I could change, for example, instead of this, I could say grayscale or false color step. So different different options here, and we can also change our units from candela per meter squared, nits, to foot lamberts or millilamberts. Okay. And lastly on this, if I was actually interested in radiance measurements, all I need to do is go to Ray Trace options, switch this over to Radiometric, and now I'm in watts per meter squared per steradian. So quite easily able to do that. So that's how to set up luminance, a couple different ways to set up luminance and photorealistic rendering. Oh, I didn't mention that here. If we are in, I'm going to go back to my radiant photometric units here. And in the options, I could pick true color. And we have some saturated pixels, but it's blue. So we could also do some lit appearance photorealistic rendering this way as well. Okay, so what I wanted to try to show you there is just, it's pretty easy to set these up in TracePro. And if you wanted to add another point here, we could say luminance 2, give it a different eye position. Let's say it has an X of 25, 35, mistyped it. Click insert. And there's a second position we're looking at it from off axis. So now when I run this, I'd have 2 ray traces, or I'd have 2 plots that come up. One for straight on, one for off axis at an angle. So very easy to do that. Okay, so last little section here, and I should remind everybody we do have a few questions coming in. Please feel free to send in any questions you have, and we'll address those in just a couple minutes. So a couple of precautions or cautions here in terms of luminance, radiance, and photorealistic rendering in TracePro. One is, do not leave a perfect absorber object or a target object in between your eye position and your target. So don't leave something in between the eye position and the target that's going to absorb the light. You get a blank screen. Next one, sort of start with a small window, or if you're doing the other radiance luminance maps, large pixels, and a low number of rays or photons to make sure all the settings are correct. I always say start small. Start small, something that's going to run relatively quick, maybe in a minute or less, because you want to make sure you've got your settings correct before you commit to a long luminance radiance ray trace. Okay. Once the initial results look good, well, then go ahead, increase the window size and the number of rays, or decrease the pixel size for a better resolution. Watch out for luminance radiance values that may exceed the dynamic range of the luminance radiance map. So sometimes it's possible that you have values where you have a very high luminance spot and a very low luminance spot, and you're only going to be able to see the high luminance one. If you're using the photorealistic rendering option, there is a log scale option there that you can use for that. Another one, if you're running a long rendering or luminance or radiance ray trace, turn off Windows Update. My sort of story here is that one time I was running one early on when we first developed the photorealistic rendering tool. I had a luminance radiance map that had been running for almost a week, and it was at 99% complete. And that night, Windows updated the computer, and it shut the computer down when I was almost to the very end. So I lost my week's worth of luminance radiance ray tracing. So just remember that. And then lastly, did I mention, don't leave a perfect absorber between the eye position and the target. The fact that I mentioned that twice tells you probably the number of times I've made that mistake myself. So just learn from what I've learned the hard way. Don't make sure don't have objects between your eye position and your targets, unless they're things like lenses. Then that's okay. So just a quick summary, and then we'll jump into the questions. Luminance, radiance, and photorealistic rendering simulations are a really important part of many types of designs, especially things like light guides, backlights, and displays, things that are meant to be viewed. In TracePro, we have several tools for doing luminance, radiance, and photorealistic rendering ray traces. And lastly, I hoped in that last little section I showed you that these are easy to use and set up. So there's really no reason not to do them for certain types of applications. And then to wrap this up, if you'd like more information, please contact us at lambdares.com or our phone number there, 978-486-0766. That's a US number. Or email us directly at sales@lambdares.com. And we do offer free 14-day trials for qualified users. So again, if somebody's interested in that, please contact us at with one of those methods below. And as I mentioned earlier, we are recording this webinar, so we will be having a copy of this up on our website within the next day or so. So please feel free to come back, look at it again if there's any questions, but also definitely questions, please feel free to contact us. So with that, I want to thank everybody for their attention, and I'm going to jump into the questions here. Does the angle of radiation affect the illumination? Yes, it depends on what type of illumination. If you're looking at light hitting a surface, then yes, the angle will have an effect. If you're also looking at luminance or radiance, the angle you are off axis from that is definitely going to have an effect. So yes, angles can have very large effects. Can we find out the lux of a light at different distances using the software? Yes, quite easily. Just add in targets or just add in surfaces where you can measure the lux at multiple distances. You don't need, matter of fact, if I go here, let me get out of that. If I had this model here, and not the best example for that, but if I added in geometry, primitive solid, and I added in a target that, let's say it is 40 by 40 and it's at 50 millimeters. Oh, make it a little thicker so we can see it. So it's there. Then I could add in another one at 100 and at 150. So I'd have three targets here, 50, 100, 150 millimeters. I could run a ray trace, and then I could look at the radiance illuminance map in TracePro. That's a different webinar. We do have a webinar on the analysis tools in TracePro, but very easy to do. And the only sort of trick here, and it's not even a trick, but don't apply any properties to these objects. That way they won't interfere with the rays. The rays will go right through them like they're not there, but you still have a surface now where you can look at things like your radiance and illuminance. Luminance unit is very confusing. Can you please explain candela meter squared unit, like what is the area and candela signifies here? So yes, luminance is very confusing. It can be, I should say. So let's see here. Let's go back a bit. And we look here. In a luminance measurement, and we'll stick with the visible one now, candela per meter squared. Candela is broken down as a candela is actually lumens per solid angle, lumens per steradian. So it's lumens into a given solid angle. Think of a solid angle. Think of a cone as part of a sphere. And that cone has a certain solid angle. It's a three-dimensional angle. So we're looking at the number of lumens into that solid angle. So that's what candela is, lumens per steradian. Now that light illuminates a surface, or that light comes from a surface. The light's coming into a certain area, but that surface it's coming from has a certain area as well. So if we look here, our light's being emitted from this, let's say this was a screen, like an old movie screen. We're illuminating that movie screen, so we're illuminating a large area, and then your eye or camera is looking at that screen, and you're seeing a part of that screen due to the viewing angle of your eye. I mean, it might be the whole screen. So your eye has the angle there, and that's sort of the candela part of it. The light's going into a certain angle as it comes from this screen. And then the meter squared part is the size of the source area. So it's a combination of two things, combination of viewing angle and combination of emitting area. So it can be, you're not alone in being a little bit confused by it. It does take a little bit of, it does take a little bit of time for it to kind of sort of sink in. Can you talk about the accuracy of the two methods? Well, they should give you the same results either way. But as with all computer simulations, there's a term I learned years ago called GIGO. Garbage in equals garbage out. So you need to make sure your model is set up correctly. You want to have, your properties correct, your sources correct, your wavelengths and spectrums correct. So the more detail you can put into the model, the better the results are going to be, the closer to being, true to life that they will be. So you need to put that sort of homework in to make sure you're getting those good results. And I always like to back it up with a measurement, especially when I'm first going through it the first few times. Do humans perceive luminance linearly? Does doubling the luminance look twice as bright? Now, my understanding has always been that we actually don't, that your eye is sort of a logarithmic type scale. So I don't think doubling the luminance is going to be exactly twice as bright. It's more of a logarithmic type relationship. I don't know if it's straight log, a log type scale, if there's something, for a little bit of a modification of that. Okay, that was the last question. Nope. Any limitation on the types of sources you can use? File sources and surface source properties. I don't believe we can use grid sources at this time. I got to double check that, but I believe right now it is file source and grid source. I'm sorry, file source and surface source. Previously, up until a couple years ago, it was surface source only, but now our programmers have modified it so we can work with file sources as well. So if you download a RAY file from an LED manufacturer, that you can use that. Just note the limitation of RAY files is that in most cases they're single wavelength. So if you're really looking for color, you may not be able to get it with RAY files. Not due to a limitation in TracePro, it's due more to a limitation in RAY files themselves. Okay, well, we're coming up on the top of the hour, so I've had everybody here for an hour. I'd like to thank everybody for attending. Thank you for some good questions there as well. If anybody does have any additional questions, please feel free to send them to us. And I mentioned we will have a recorded version of this webinar up on our website pretty soon. So with that, thank you again. Thank you everyone again. I hope everybody has a good rest of the day, and I look forward to seeing everyone at our next webinar. Bye.